So yesterday, we looked at the graphs of parabolas using factored form. Today we're going to look at the graphs of parabolas using standard form and vertex form. So starting out with the second equation, which is in standard form. So standard form, in case we are not registering what that is, remember is going to be our expanded version of the polynomial. So it's when it's in that form. We're going to first find our vertex, and then we'll find our y-intercepts and our x-intercepts. So our vertex, we are going to have our x-coordinate of our vertex we get by doing the opposite of b divided by 2a, and the y-coordinate of our vertex we get by subbing opposite of b over 2a, or our x-coordinate of the vertex into our equation f of x for x. So let's go ahead and do that. A for our equation is 1 because it's 1x squared. B is 6 because it's it's 6x, and C is 3. So our x-coordinate for our vertex is going to be the opposite of b, so negative 6 divided by 2a, so 2 times 1. Negative 6 divided by 2 is negative 3. Our y-coordinate of the vertex we get by substituting that value into our equation, so we can do f of negative 3. So instead of x in our equation, I'm going to now have negative 3. Negative 3 times negative 3 is 9. 6 times negative 3 is negative 18. Plus 3. When you combine those, you'll get negative 6. So my vertex, trying not to sneeze over here, that's negative 3, negative 6. All right, so that's our first portion that we know. Now we need our y-intercepts and our x-intercepts. So then just write the equation over here again for us. Of course I can't remember it offhand. X squared plus 6x plus 3. So y-intercept, so this guy occurs when x equals 0. So we're going to substitute 0 into f of x for x. So f of 0, replacing all of the x's with zeros. We're going to get a y-coordinate or an output of 3. So my y-intercept is 0, 3. My x-intercept is a little bit more work. So my x-intercepts, if there are any, occur when my y, or my f of x, is equal to 0. For standard form equations, that aren't factorable, right, we're going to have to find that by using the quadratic formula. All right, so let's go ahead and do that. Remember where a was 1, b was 6, c was 3, So x is going to equal to the opposite of b, negative 6, plus or minus b squared. So 6 squared minus 4 times a of 1 times c of 3 divided by 2 times a. So 1. So we got negative 6 plus or minus the square root. 6 times 6 is 36 minus 12 divided by 2. Right? The plus or minus means we're going to have two values. So we have the addition value, yikes, if I can speak, and the subtraction value. So we're going to have two x-intercepts. And then we're going to go over simplifying radicals in detail together, right? But basically when we do that, we say what's the biggest perfect square that goes into the number under the square root. But for today, I'm going to let you off the hook, so to speak, and we're just going to find an estimate by plugging this into the calculator. So we're going to do negative 6 minus the square root of 24, and then divide by 2. When you do that, you're going to get negative 0.55. And then when we do it, the opposite way, so we do it with subtraction instead of addition. You're going to get negative 5.45. So our x-intercepts are negative 0.550 and negative 5.45, 0. So I just need to steal my other information. So I've got negative 3, negative 6 as my vertex. These are my x-intercepts. My y-intercept was 0, 3. All right, let's go ahead and graph this guy. Since my coordinates are negative, I'm going to go by halves on my negative side and ones on my vertical. Our lowest point is negative 6. And then my furthest point is negative 5.4. So I need to get to that. All right, so negative 0.50 would be about here. Then I've got 0, 3. So we'll just label these as we go. And then we've got negative 3, negative 6. And negative 5.45, 0. And we've got our parabola that place connect the dots. There we go. All right, so that's standard form. Vertex form is going to be a little bit faster. All right, so vertex form, we're looking at our last one here. So the nice thing about vertex form is our vertex we can get just from looking at our equation. So our vertex is going to be the opposite of this value and the same as this value. So our vertex is h, comma k. So the opposite of h in our equation up there is -5, and the -1 is our k. So we found our vertex. Nice and easy, right? Y-intercept still when x equals 0. So we substitute that in for x. And then x-intercepts are still when our y, or my output, is 0. So this is like solving an equation with a square root, which we've been over before. So the first thing you have to do is get the expression that's squared by itself. Then we do the square root. We need to remember a plus or minus. Square root of 1 is plus or minus 1. This one cancels out, so you got x plus 5. Subtract 5 from both sides. We've got -5 plus or minus 1 equals x. So break it up into your two cases. -5 minus 1, -5 plus 1. And we've got -6 and -4. So -6, 0, -4, 0. And now we've got everything we need to graph our equation. All right, we have to get quite high, so I'm going to make every tick mark 2. So -6, 0. Vertex is -5, -1. Then we have -4, 0. And 0, 20, 0, 24. So we graph this guy. And we call it a day.